Hi everyone, I'm going to start you with 4.3 notes part 2. This is on your same sheet of guided notes if you are following along with that, just part way through, and you'll notice at the top it'll say day 2. That's where we're starting with this set of discussion. I want to start with a quick review of your special right triangles that we've talked about. We know that one of them is your friend, the 30, 60, 90 right triangle. And if we are working off of that, I'm going to say that our short leg here is 1, the hypotenuse is 2, and our long leg is square root of 3. Sometimes you'll see that written if you want it in a generic format. 30, 60, 90. We could say this is x. This one is 2 times x, and over here is x times the square root of 3, if you prefer. We also know that our other triangle, special, 45, 45, 90. If the angles are the same, the sides are the same, which I marked already. Let's say this is a 1, and that would make your hypotenuse the square root of 2. And if you want that in kind of a generic setting, if we do a 45, 45, we could call the legs x, and then that hypotenuse would be x times the square root of 2. Okay, so let's take a look here. If we want to find all trig ratios using some specials and also tie in from our previous lesson some reference angles. All right, so let's begin with 60 degrees. All right, so 60 degrees, if we're thinking about the coordinate plane, is going to be over here in our first quadrant. All right, so we drop in here a 60 degrees. We could drop in right angle. So if that's the case, we have a 30 up here. On the x-axis would be a 1. Coming up the hypotenuse side is a 2, and over here on the vertical is square root of 3. Okay, so then we could say that the sine of 60, using SOHCAHTOA, remember, you need that over here to the side. Whoopsie. Can't talk and write at the same time, kind of a problem. SOHCAHTOA, there we go. So sine is opposite over hypotenuse, so we'll have square root of 3 over 2. Cosine 60, adjacent hypotenuse, so that'd be 1 over 2. And tangent 60 should be square root of 3 over 1, or just square root of 3. And then we keep going for the reciprocal function, cosecant of 60. Here we go with me and my writing again. There we go. Cosecant of 60 is 2 over the square root of 3. And yes, we could rationalize. We're going to just leave it that way for writing ratios for right now. Reciprocal here, 2 over 1, or just 2. And lastly, cotan, 1 over the square root of 3. Okay. All right, second one, let's try negative 210 degrees. Okay, negative 210. All right, so we've got to think about where that is. So we know negative is going to come around this way, clockwise. And we get over here to the line, we know that's at 180. So we've got to keep going just a little bit further. Okay, so we're back up this way in the second quadrant. So you have to think about, I don't think yellow is so good. Got to think about what is our angle going to be to create our triangle this direction. Okay, so if you remember, you have to figure that reference angle back to the x-axis. So if you're at 210 and we've got to back that to the 180, that's going to drop us in here at 30 degrees for our reference angle. Okay, so what does that look like? Well, our short leg can be 1. Hypotenuse is still 2. And down here on the x, we're going to have negative square root of 3. Now you're thinking, why is it negative? You're in a triangle. Well, remember, you're in the second quadrant. So that means coming across here, your x value is going to be negative. Okay, so then if we go through and we write our ratios, the sine of negative 210 is going to be opposite over hypotenuse, so we should have 1/2. Cosine negative 210 is going to be negative square root of 3 over 2. Tangent negative 210, negative 1 over well, that's fine. Negative 1 over the square root of 3. All right, cofunctions or reciprocal functions. Cosecant negative 210 is 2 over 1. Secant negative 210, 2 over negative radical 3. And then cotan negative 210, negative square root of 3. Okay. Lastly, let's try something like, oh gosh, I don't know. Let's try, maybe that was enough, but we could throw in here, how about 1 in radians? What if we do like 7 pi over 4? Seven pi over 4 radians. All right, so we start at 0, pi over 2, pi, 3 pi over 2. Where's 7 pi over 4? Well, you could convert this. 7 pi over 4 times 180 over pi. So we could convert it to degrees if we really wanted to. So the pi's would go away. You could reduce this down to 45. So what's that, 225? Or 325. Looks good to me. I'm probably showing you this way and I shouldn't. That's why I'm hesitating. How about 315? How about 45 times 7? Yeah, 315 would be better. It's like, where did I learn how to do math? No comment. All right, so that's going to bring us all the way around here to the 4th quadrant. Okay, now, let's suppose that we left this at 7 pi over 4. Okay, so now I know that's 315 degrees. All right, so then what's our reference angle going to be? If I drop that down in here, back to the x-axis, we've got to find out what that reference angle is. Okay, oh, I hear you. 45 degrees. You are correct. Better known as pi over 4. Okay, awesome. So if that's true, we know this angle here is 45. You have your 1's, you have your square root of 2, and actually the one on the right side here is going to be negative because it's coming down. You got a negative y. Alrighty, so if we go through our process, sine of 7 pi over 4 should be negative 1 over the square root of 2, or negative radical 2 over 2 if you really want to rationalize it. Cosine 7 pi over 4 is going to be actually the same thing, right? Except positive 1 over the square root of 2, square root of 2 over 2, and then tan comes out to be negative 1. Okay, and then you can write your other cofunctions, but let's keep going here. All right, quadrantals. Angles whose terminal side lies along one of the coordinate axes. There's no triangle, okay? R will be equal to either the x or the y value. Okay, so let's see what we've got here. Quadrantal up here at 90 degrees, okay? So on the axis, let's say we have 0, 1, okay? And in this case, R is going to equal 1. So we're going to have the sine of 90 is going to be 1. Cosine of 90 is going to equal 0 over 1. So 0. And then the tan of 90 is undefined. Okay. Cosecant of 90 is 1. Secant of 90 is going to become undefined. Remember, you can't divide by 0. Cotan 90 is going to be 0. All right, so that's the first quadrantal. Okay, let's suppose we do pi. Okay, so this first one was for 90. Let's do pi. So we come across over this way. So we're at -1, 0, and in this case, r is going to equal 1. Okay, so then you drop in here sine of pi is 0, cosine pi, -1, tangent of pi is 0, cosecant, undefined, again, because it would divide by 0, secant of pi, -1, and cotan, sorry, I'm trying to go too quick for you probably because I didn't want this to be so long this time, undefined. Okay. All right, so the last thing I was going to have you take a look at, actually maybe two things to take a look at. Find the trig ratios. Trig ratios positive in which quadrants, okay? Well, what I like to think of when I do this one, okay, I have my 4 quadrants. And I picked up on this little phrase, all students take calculus as you go around. Okay, so what this does is it gives me a way to remember which ratios are positive in which quadrant. Okay, so like here in this first quadrant, this tells me that all 6 are positive. All 6 trig functions are positive. In the second quadrant, sine is going to be positive. So if sine is positive, cosecant's positive. Okay, in the third one I have a t, so that means in the third quadrant, tangent's positive. And then in the fourth, I have cosine, so in the fourth quadrant, cosine's positive. Okay, so in the first, all are positive. In the second quadrant, the only thing positive is sine. In the third, only thing positive is tangent. And in the fourth quadrant, only thing positive is cosine. Okay, so if you can remember, all students take calculus as you go right around. Okay, hopefully that'll help you remember who's positive in which quadrant. Nice little way to remember it. All right, lastly, I want to do a little example. If I give you one trig ratio, like here's an example. The sine of theta is equal to 3/7. And I also give you a clue like the tan of theta is less than 0. Can you solve for the other 5 trig ratios? Okay, well, start with a picture. You know that sine is opposite over hypotenuse. Okay, we also know that tan is going to be negative. So we have sine positive, tan negative. Okay, sine positive, tan negative. Well, the only place sine is positive is in the first and the second quadrant. Okay, where is tan also going to be negative? Well, that tells me quadrant 2. That's the only place tan's going to be negative and the sine is positive. So that means this direction, I have a hypotenuse of 7, and I have opposites 3, okay, because in here is going to be my angle. All right, bring that back over here. Okay, so then I need to first find out what that x value is going to be. All right, so if we do something like 7 squared equals 3 squared plus x squared, little Pythagorean theorem there, you're going to get 49 minus 9 is 40. So x is going to be the square root of 40. And actually it's going to be negative because we're on the left. We're on the negative x-axis. Okay, so then once you have that info, we can go through and do cosine, negative square root of 40 over 7. You can do tangent, 3 over the negative square root of 40. Cosecant, 7/3. And I'm missing my thetas here. Secant, 7 over the negative square root of 40. And cotan is negative square root of 40 over 3. Okay? All right, so there's a quick example of that. You've got your quadrants where things are positive, negative. We talked briefly about the quadrantals and how r is going to always equal to either the x or the y value, depending what you've got. Yeah, I think that's pretty good. Be sure to bring your questions to class, and we'll see you soon. Thank you.